All right, so first of all, we are going to just consider this. What's the answer?
2.
2. In other words, what exponent do we replace the x with to make it true? And we all know that 2 squared is equal to 4. So first of all, this is an exponential equation. And exponential equations have the x, or whatever variable, generally speaking, we're going to be using x for now. When we do applications, then sometimes we use a t or something like that, but have the x in the exponent. Now, like everything probably you've experienced in math class, yes, we know that the answer is going to be 2. We already know that. But as they get harder, you are not going to be able to solve it just by inspection. So you are going to have to, we have to have a different method. So the easy ones are very easy. You'll kind of just know the answer, and we're going to explore those to start, but we're going to get into some already more complicated ones today, and then we're going to do a second day on this. And by the way, that will wrap up the unit, right? And then we're doing a couple days in review and having a test. But that's the idea is how do we show our work properly? What do the steps look like to actually solve this? That's the other part that you're going to be exploring, okay? So what we actually do is we write both steps with the same, or sorry, both sides, left side and right side, with the same base. And we ask ourselves, what exponent do I put on the other side to make it turn into that? And as we said, it's 2. And when you have written both left side and right side with the same base and then some exponent, we say, well, if the bases are the same, what has to be true? The exponents have to be the same, right? There's nothing else about the equation. If you have other junk, well, then it's not going to work. If you got like +7, okay, that's not going to work. But as long as all I have is 2 to the something equals 2 to the something, those somethings have to equal each other. So we're kind of just using logic, and we go, therefore, x equals 2. I got to change this example. It's so confusing because there's too many 2's involved, and you forget which 2 comes from where. So we're going to do one more. 2 to the x equals 8. It's not always 2, by the way. There's lots of other bases that we're going to explore. So it's going to be 3, but we're not just getting the answer. We've got to know how to write it. What exponent do I have to write it as a power of 2. Because the 2 to the x means I have to be able to write the other one as 2 to the something. Okay, it'll always work out that way. And you put a 3 in there to make it equal the 8. And you say, therefore, x equals 3. And you need the therefore statement because we're not actually performing an operation. We're just drawing a conclusion. We're just saying, if the bases are the same, the exponents have to be the same. Therefore, this must be true. And sometimes there's more steps, but they're kind of grade 9 steps. So from there, it's not really going to be hard. The new part is how to write it and just the concept of how you solve them in general. Okay, so I'm just going to make a note of this. If the bases are the same, then the exponents must be equal. So again, for example, 2 to the a equals 2 to the b. A has to equal b. Or even better, any base. It doesn't have to be just 2, like I said. X to the a equals x to the b. A equals b. Any questions? There's one common mistake. I'm going to show it to you in the next example that we're going to do. Part of your job is to not write it in the common mistake way. And there's a reason why it's a common mistake, because it's the intuitive way. It's the way that you're thinking. So it's the way that probably, at least for now, will make the most sense to you. But you got to trust me. You're not allowed to write it like that. Form always counts. And when the questions get harder, doing it that way won't really work. It's kind of like back in grade 9 when your teacher was trying to get you, and grade 8 for that matter, was trying to get you to write bed mass questions the right way. And there's a intuitive way that you kind of want to write do those questions, but it falls apart eventually. So you got to break those habits. It'll be the same thing here. When we do a learning goal in a couple of days on this, I don't think we'll do one tomorrow, but probably Wednesday. If you're making that mistake, I will tell you, and I'll say form, show your work properly kind of thing, and you'll have to be mindful of that. All right, now we're going to start with another easy one, and then sort of get progressively a little bit harder. Is 32 a power of 2? It is. So you might not know which, but hopefully you recognize that it is. And if you've been doing the practice, you've seen 32 come up a lot. So you kind of like, oh yeah, which one is it? And you say to yourself, all right, maybe it's 2 to the 3. Nope. Maybe it's 2 to the 4. Nope. Maybe it's 2 to the 5. I got it. So on your calculator, you might be doing a little bit of guess and check if the numbers start to get a bit bigger. But you know, you can guess that it's going to be probably a power of 2. Occasionally, it's going to be a bit different. We'll look at those questions in a moment. Okay. So 2 to the x equals 2 to the. You don't actually have to draw the box if you don't want, but that's my way of saying, like, this is what you're thinking. This is what you're. Like what your brain is doing. What exponent do I put on the 2? So it's the 5. Very good. And you might already be thinking, okay, this is easy. I can do this. Well, good if you are thinking that, but it does get a little bit harder. This is what you don't do. Whether you write this down or not, I don't care. But pay attention to it and don't solve them this way. 2 to the x equals 32. 2 to the 5 equals 32. Therefore, x equals 5. At first glance, there doesn't look to be anything wrong with that. You might even not really notice the difference between the two, and you kind of say, who cares if I show it one way or the other? Well, first of all, it's not the way that we do it. Second of all, you got to trust me, when the questions get harder, that method doesn't work as well. Anybody else notice something a little weird about it?
It's not going to tell you what x is.
Yeah. The second line doesn't even have an x in it. It doesn't really flow. Like when we do math, every line follows from the one above it. Obviously, if you wrote that, everybody knows what you mean, and then you got the right answer. X is 5. But we try to keep our solutions consistent. There should be an X on every line. It can't just disappear and reappear. That's one of the other kind of problems with it, which is a form thing. But also, trust me, when the questions get harder, that way doesn't work. What's different about this one?
There's a number and an exponent.
Yeah, there's a number in the exponent along with the x. So it is an exponential equation because x is in the exponent. If we're using this method that we're using, it's the same thing. You just write the whole thing down. 64 is what power of 2? Oh, I thought you were going to. What do you think?
6.
6. What am I going to write on the next line? What's my next step?
Is it 6 divided by 2?
Well, I'm going to do that eventually, but I'm going to write a different line first. So we equate the exponents. Whatever they are, we set them equal to each other. And then TK is exactly right. We divide both sides by 2. And in this case, x is 3. One of the pitfalls of doing it the way I just showed you that we don't do it is sometimes people say, therefore, x equals 6. But it's not x. It's the exponents are equal to each other, whatever they happen to be. Okay? So doing it this way does generally protect against that, but also, trust me, it's a better method in the long run. Still pretty straightforward though, right? Still feeling okay about this? Yeah. All right, moving along. Try this one on your own. Remember at the beginning of this unit, I said, if you know some of these, you're going to be better off, right? If you know some of the powers of 2, 2, 4, 8, 16, 32, 64, 128, 256, you don't need to know that high. If you know some of the powers of 3, like up to 3 to the 4, that's probably good, right? 4 to the 3, 5 to the 3, and then all of the squares, 6 squared, 7 squared, up to whatever. The more you know, the easier this is going to be. And if you don't know one, well, that's when you start guessing.
It's 3.
It's 3 to the 3. So again, we know that the base is going to be 3. So you just, well, it's not 3 squared. I hope we all know that. Try the next one. Or do it in your head. What's 9 times 3? Right? That's the same as adding another power. Okay, good. So did you get that? X is 3. That was another easy one. Ooh, what's different about this one?
After the equal is small, this number is smaller than the base.
The number is smaller. Yep. What else? You may not notice this, or you may not know how to put it into words, but there's something else about this one that's different.
You have to put it in a smaller.
Yeah. You can't turn an 8 into a 4 or a 4 into an 8. I mean, you can, but not easily. Right? Is 8 a power of 4? Then the smaller number could be on either side. That can happen, obviously, right? Like, that can happen. But can you turn an 8 into a 4? Can you turn a 4 into an 8? Like, it doesn't work. So in this case, we can turn them both into
2, correct?
2. They're both powers of 2. 8 is 2 to the what?
4, 3.
3. So 2 cubed is 8. So that's 8 to the x. And 4 is 2 to the 2. What's the rule when I have a power of a power?
He multiplies the powers.
Multiply. Now I have the left side and right side written with the same base. Do you agree? Divide both sides by 3. And that's why this was a harder one, because the answer is a fraction. See, the first examples that we did were so easy, you kind of think to yourself, well, I can just do this in my head. Why do I need to show the steps? Did anybody just know the answer was 2 over 3 when they looked at that question? No. I mean, even I don't look at it and say, oh, it's 2 over 3, right? Could you do the work in your head? Keep track of both sides? Yeah, sure. At least some of us could, right? Like if you have good sort of working memory and you're able to hold numbers in your head at the same time, you might be able to do it without writing stuff down. But that's not solving by inspection. That's just doing the steps in your head without writing things down, right? Solving by inspection is when you can kind of just look at it and you know the answer is 5 or whatever, okay? So we're already starting to see how important it is to have a procedure, right? A method that's going to work in all cases for questions that can be a little bit more challenging. Stop me if you have questions, otherwise we're going to keep moving on. What's different about this one? Subtle differences, little things. Both have an x. What if you had one side x in the exponent, the other side x not in the exponent? You can't solve it. Not with the math we learned in this class. Okay? So they'll always be both in the exponent. So 4 is obviously 2 squared. The other thing that you might have noticed it's different is it's a binomial. It's x minus 1, right? So that's not really going to change things too much, but subtract x from both sides. And we're done. Nice thing about equations, even if it doesn't ask you to, you can always check your answer. And I always say you'd be crazy not to when you're doing a test. Like if you got an extra 20 minutes, why wouldn't you sub that back in? Right? So if I put -1 in for x on this side, I get -1 minus 1, which is -2. What's 2 to the -2?
-4.
Nope. Think about it. What do negative exponents do?
4.
Huh?
Is it 4?
It's not exactly 4. This is what we just finished. And I told you you'd forget. We just had a quiz on this. 1 over 4. 1 over 2 squared, which is 1 over 4. I guess it was a long weekend, eh? And then on the other side, I take the -1 and put it in. What's 4 to the -1? 1 over 4. So there's your, informal left side, right side check to see that they're both left side equals right side. Therefore, x equals -1. Try this one if you like. Not 2. It's not 3. We just did that one. If you forgot already, then maybe you check 3. But it's not that. Do you think it's going to be 10? Like again, as you practice, I hope that you start to get more familiar and more confident with just kind of how these grow. They grow fast. What is it? 4. So it's the next one, right? So interesting that 3 cubed is only 27, 3 to 4, there's 81. Like, that's a big jump, isn't it? But these do grow quickly. So you might be like, oh, I'll try 10 because 81's a big number. Whoa, 60,000. Like, that grew really fast, right? So you don't want to jump up too high too quickly when you're checking these, when you're doing the guess and check. 3 to the 4 indeed is 81. What do I do for the next step for this one? Multiply both sides by 4. Or sorry, by 6. Right? People also put the therefore on the wrong line. It's not going to be a big deal. I'm not really too worried about that, but it doesn't make any sense to put it somewhere else. Like, you're not just saying, therefore, x equals 24. It's not just a summary statement. It's always at that line where you're equating the exponents, and the reason is because we're not doing an operation. We're just drawing a conclusion. We're using logic. It's deduction, If the bases are the same, the exponents must be the same. Okay? So that's why there's the therefore. So try to get on the right line. Okay, this is similar to that other one we did where we've got a 4 and an 8, so we got to turn them both into powers of 2, right? See if you can at least finish that first step. So 2 to the 2 and 2 to the 3. And then I multiplied the exponents on the left side. 2 times x over 10. And if you wrote 2x over 10, that'd be fine. You'd still be able to solve this question. But I simplified to get x over 5 equals 2 to the 3x. Therefore, x over 5 equals 3x. And this is where, like I say, these are really grade 9 kind of questions, just solving simple-ish kind of equations. Multiply both sides by 5. Bring all the x's to one side and everything else to the other. This is a bit of a weird one. It's funny. Sometimes you get these, like it doesn't look complicated, but there's something about it that just is weird because there's only x's and no other numbers, and it causes you to kind of muck up. So that's where the practice comes in. Subtract x from both sides. 0 equals 14x. So divide both sides by 14, or we just know that x is 0. Any questions about that? Mm-hmm. So if it was like this, 15x equals x plus 28. I'd subtract x from both sides and get 14x equals 28. Then divide both sides by 14. And x would be 2. It's just weird because it's a 0. You end up with a 0, so something feels like it's missing a whole part to it. But you just got to make sure you remember that it's 0. All right, a couple more examples. 0. So this one's a little bit different because there's fraction. Oh, that's what I was going to say. Hold on. Before we do that one, I want to say, I bet some of you are already thinking, like, do I have to show all these steps? And like, okay, you definitely don't have to show that step if you can go straight to that. Okay. Yes, you can simplify this to some extent, but be careful. Don't skip too many steps or cut too many steps. Okay. But are we going to get to any? Yes. Oh, no, we're not. And in some cases, I'm kind of okay if you do a little bit of work when you get to this step, but not too much. Like you could even go from this straight to that. That would just don't go crazy. Okay. You gotta at some point show that step. You gotta show your work how you're simplifying. You can't just jump straight to that. But I am sort of over showing my work because it's a lesson, right? Okay, so can I write 16 as a power of 2? Yes. So what I'm going to say is with these hard ones that have fractions, do that first. So 2 to the 4. but these aren't the same base. One of them is a fraction, one of them is not. Yes, they're both 2 to the something, but this is a fraction, so it's not the same thing. So what do I have to do next?
You write it as a whole number, but with a negative.
Very nice. So 2 to the x equals 2 to the negative 4. So doing it in 2 steps like that makes working with that negative easier. Again, if you're nailing this and you totally get it and you want to do that all together, that's fine. But if it's causing you to make mistakes, then that's how you go back and show your work. Just think about the number, then realize that to flip it up, you put a negative out front. Okay? And that one's done. Try that one if you like. So first of all, you got to write 27 as a power of 3. It's 3 cubed. Bring the 3 up by putting a negative in front of on the exponent. Now I've got 3 to the something equals 3 to the something, so the somethings have to be equal to each other, the exponents equal each other. Divide by 2 and we're done. Okay, we're almost done. A couple more. I'm going to do this one 2 ways. You don't have to write them both down. The second way I'm probably not going to finish because we'll already know the answer. But when we do it the second way, you'll see why somebody might tried it that way. This one's already set up, isn't it? The bases are already the same. So we can just go straight to the answer. So this is the easy way to do it. Easier. Like, why not? Okay, so I'm going to move the x's to the left and the numbers to the right. What's the other way that somebody might have tried this one? Anybody have any ideas? Oh yeah, I could have done it that way. That's not what I meant. Like I could have solved that and avoided the negative. Would have been done in one step. Back to the original question though. Yeah, put the bases to be like a 2, right? Because that's kind of what we did before. And you think, well, I can write 8. Both of the 8s is a power of 2. Well, yeah, you can, but why bother, right? It's just going to add a bit of extra work. But I want to show you what it looks like. So if you copy this down or not, doesn't matter. This is 2 cubed to the 2x minus 1 equals 2 cubed to the 3x plus 5. So that's 2 to the 3 times 2x minus 1. So you end up with like distributive property question. So 3 times 2x is 6x minus 3, 9x plus 15. So see, I expanded and equated them. So if this comes up, that's okay to do it that way, or go straight from this step kind of thing. Okay, and then we would solve from there and we'd get the same answer. But it's a lot more work, so why bother? Okay, 2 more. whoops, there's nothing all that interesting about these two, so let's just fly through them. The only thing is whoops, what just happened? Okay, that was weird. Oh, that's what happened. Uh-oh. Okay, let's try this. If the base is negative, the other base has to be negative as well. This one works out. What do I put on the other side? It's just 2. Is negative 5 all squared positive 25? Yes, we've talked about that, right? Therefore, x equals 2. Whereas if I'm not squaring it, negative 5 to the so just 3. Because negative 5 to the 3 is negative 5 times negative 5 times negative 5. 3 negatives will make the result negative. Okay, remember negative exponents make fractions. And if you just think about those two last ones, what if it was like this? Well, you can't do that one, right? Because negative 5 squared doesn't give you negative 25, it gives you positive 25. So that's not really something that's going to come up. I guess the lesson is you can't make up your own questions with involving negatives because they might not work. But this one's positive because you're squaring it. So any even exponent will give you a positive, whereas this one's negative because it's an odd exponent. Okay, that's really all.